Hi guys, so today we're going to do the 2010 AP Physics B free response question, Form B. I kinda already did my work, Mr. C. Sorry, ran out of paper. So it says 3. Two small objects, each with a charge of negative 4.0 Newton coulombs, are held together by 0.02 meters length of insulating string, as shown in the diagram above. The charges are initially at rest on a horizontal, non-conducting, frictionless surface. The effect of gravity on each object due to the other is negligible. So A wants us to calculate the tension in the string. So F is equal to MA, and you also want F to be equal to all your forces. So you're going to use MA equals T minus KQ squared minus R squared equals 0. So T equals KQ squared over R squared. When you plug in, you'll have 9 times 10 to the 9th Newton per meter squared divided by Coulomb squared times negative 4.0 times 10 to the negative 8th coulombs over 0.02 meters squared. That gives you an answer of T equals 3.6 times 10 to the negative 4th newtons. B, it wants the electric field for the two objects in the following diagram. So because you have two negative charges, they're going to be repelling from each other, but you're going to have stuff going into negative. So you have your lines drawn such as there. So now you have each object has a mass 1 of 0.03 kilograms and the other is 0.06 kilograms. The string is cut, so it wants the initial acceleration of each object. So you have ma is equal to t. So when you manipulate that, you have a equals t over m. So m1 is 3.6 times 10 to the 4th newtons. So let me fill that in. Newtons, divided by 0.03 kilograms, which you get equal to 1.2 times 10 to the negative 2 meters per second squared. That's for mass 1. For mass 2, you do the same thing, only instead of 0.03 kilograms, you use 0.06, and you get 6.0 times 10 to the negative 3rd meters per second squared. So, part D. On the axes below, qualitative sketch a graph of the object of the acceleration A of the object of mass 2 versus the distance d between the objects after the string has been cut. That's what happens with your graph, only instead of it leveling off, it'll level off more like that. And it won't go back up. It'll approach 0. So part E. Describe qualitatively what happens to the speed of the object as time increases, assuming that the object remains on the horizontal non-conducting frictionless surface. Your speed will increase, and because acceleration will always be there, but the acceleration will decrease as the force becomes weaker, and as the distance d approaches infinity, speed will become constant. That's it for this video.